Hi, I'm Courtney Siegert, and I'm going to be talking about changes in bark properties and hydrology under different fire regimes in temperate forests. In the eastern United States, the use of prescribed fire as a silvicultural technique to manage for desirable upland tree species is increasing in popularity. Bark Physical properties such as thickness, density, and porosity have known associations with fire tolerance among species. These physical properties simultaneously influence rainfall interception and canopy storage, and thus are of interest across a range of disciplines. Furthermore, while these characteristics are innate to a species, it is unknown whether repeated exposure to fire facilitates physical change in bark structure and whether these changes are consistent among species. To answer these questions, bark samples were collected from mature loblolly pine and chestnut oak trees from sites across the Bankhead National Forest in Alabama in the United States under three different burn regimes starting in 2006, with a 3-year return cycle for prescribed fire, a 9-year return cycle for prescribed fire, and no fire. Samples were analyzed in the laboratory for bulk density, porosity, water storage capacity, and hygroscopicity, which is the amount of atmospheric water vapor absorbed by bark during non-rainfall conditions. Drying rates of saturated samples under simulated wetting conditions were also assessed. What we found was that bark bulk density was approximately 2 times higher in chestnut oak than in loblolly pine, and was lower in both species in stands that were burned frequently every 3 years compared to stands with less frequent or no fire. This was manifested as with total porosity being approximately 30% greater in pine than in oak, and total porosity was also greater in stands burned every 3 years compared to those that were burned less frequently or not burned at all. Interestingly, in fire with a 9-year return interval, reduced bark water storage capacity in both species compared to no fire or frequent fire. For hygroscopicity, oak bark absorbed more than 40% more hygroscopic water than pines, even though oak bark had lower porosity, but only pine bark hygroscopicity responded to fire with a 25% decline under frequent fire regimes. This translated into a slower drying rates of bark for oak species, and these oak trees had lower total porosity, and more of that pore space was occupied by hygroscopic water compared to pines. The change in bark structure from frequent fire, such as lower bulk density and higher porosity, was also evident in faster drying times for both species under frequent fire regimes. Thus, our preliminary findings suggest that bark structure does indeed change with repeated exposure to fire, leading to increases in water storage capacity and slower evaporation.